So let's welcome our fifth and final speaker for today, and of all our colloquial, Fatemeh, and she will talk more about her research.
Yeah.
So
hello everyone, my name is Fatemeh and I'm a first year PhD student working with Dr. Schulte. We have been working on identifying important individuals in relational data. So the problem that we are trying to solve is define a statistical importance metrics for nodes in relational data, and we believe that important node explains features for other linked nodes. For example, in university data, we might have one course that only good programmers take it. So we can say that this course is different from the other course, and the features and parameters of the course is different. So our goal is to define and extract these nodes in a network. So the data that we are working on is Opta dataset from Manchester City, which is a detailed dataset containing all the actions around the ball by players from different teams of Premier Leagues. So it has different, in total it has 200 features, for example, number of shots, number of corners, number of tags, dribbles of a player, and to design a schema, we also extract some features for teams and matches. So the schema that we are working on it has three entities, matches, teams and players, and we are studying the relation between these attributes. So the blue line shows the relation between players and teams, which shows Silva is playing for Man City, and green line shows the relation between matches and players, which shows in that specific match against Chelsea, Silva is playing for Man City. And also a relationship has different features. For example, if the player has scored the winning goal or first goal, or the duration of his playing has been recorded in the data. So we believe that number of goals is not a good feature to rank the players and to identify the best player of the match, because 2 out of 3 of players, they don't usually score a goal. So we cannot say that midfielders or defenders are not important for a team. So we believe that ranking of football players is a hard task, because we have different types of players and we are going to rank them based on same scale. So we cannot say that we separate the features for defenders and midfielders and strikers, because some defender might play in a more attacking style, so they might be more like a striker or midfielder than defender. So we should look at all the features of all the players, no matter which position they are playing. And also, there is one more problem, that strikers in a better team tend to score more goals. So is this because they are playing for a good team, or is this they are a good player? So we should, to rank the players, we should also see which team they are playing for. So to model the data, we believe that outcome of the match is a function of player contribution, and by contribution we have taken into account number of passes, number of tags, number of dribbles, and number of shots of a player. And also we have defined a feature which is shot effectiveness, which shows how many of the portion of shots that has been ended as a goal. And we say that shot effectiveness for a team is a function of contribution of the players of that team. So in this relational data, we try to find that ties between the match outcome, shot effectiveness, and contribution of the player. To measure the contribution of the player, both players and team statistics are important, and oh yeah. We have, since we have different players for different teams, we should also consider a pool of the player to just be unbiased in considering the teams that the player plays. So at the first level, we consider the teams, and then at the second time, we don't consider the team that a player is playing. So at the beginning, we learn a base net based on all the matches that a specific team has played. So the target is only one team, and then we exclude that team and learn the base net for the rest of the data. And also we have a general base net for the whole data. And we define the score based on this formula, which is, as I said, we first have a target, which is a team or a player, and then we learn the base net based on that only that player, and then we exclude that player and then learn again, and we have also a general base net for the players or for the teams. Based on this score, we should rank the players and rank the teams. For ranking the teams, we have different measures. For example, we can only take into account the top 5 players of the team and compute the score of those 5 and take the average and then rank the teams. We have 2 different models, efficiency 5 and efficiency 1. In efficiency 5, we take the first 5, and in efficiency 1, we take the best player of each team to rank that team. So this is a snapshot of the base net that we have learned for general team and for Manchester City. You can see that in general, team formation doesn't affect the result of a match, but once we only consider Manchester City matches, team formation is important. And also, in general, the duration of playing a specific player is not important in result of the match, because in general we have so many players in a team. But when we are only considering a player like Silva, the time played of Silva defines the result of the match. So it shows that Silva is a key player for Manchester City, and he's not even the striker. So the ground truths that we didn't have any ground truths for our data, so we decided to compare the ranking with salaries of the players, and it has a high correlation with salaries of the players. And the interesting part was that for some defenders, this is only for Manchester City, but for some defenders of Arsenal, they have salary, and the defenders have a salary higher than the strikers of that team, and their score is higher than the strikers of that team. And also, this is the ranking for teams in Premier League in 2010, and we compare that with the standing of those teams in 2010, and it also has a high correlation. But we still are experimenting, and we have a lot to do. So, to conclusion, in this research, we have proposed new statistical method for importance metrics for individuals in networks, and we consider heterogeneous networks because we consider both players and teams at the same time, and we measure importance of individual for team results, and yeah, we are working on soccer data for now, but we are trying to extend it to IMDb dataset to like identifying the best actor or actress of that data too. Yeah, thanks.
So let's thank our speaker. And any questions from the audience? Well, then I ask. I love sports statistics myself, so it's very interesting. Using your results, is it possible to would be possible to find undervalued player or hidden gem? You know, the player that gets low salary but plays extremely well.
Yeah. So we are also trying to extract the hidden features, but if we sometimes get high score for low salary players, but we have no ground truth to say if our model is is not working good or that player is really good. So, you know, we need to have a judge to see that no, this player is really good, but he's getting like.
Because I personally know sometimes, you know, team buys the player, gives him high salary, and he's not playing afterwards.
Exactly. Yeah.
So that happens, and your data can show it?
Yeah, but we rank the players, but we don't have any ground truths. We just use salary. So we might be able to detect that, but we cannot evaluate that. You know.
And what about extension on other sports, hockey? American
We
football?
also have ice hockey data, but we haven't pre-processed it yet. We have started with soccer because my supervisor and I are more interested in soccer. So.
You're in Canada, guys. You will get more money if you study hockey. So one more question. Have you tried, you know, usually during match they select 3 stars. And have you tried to, you know, take the same match, get statistics from it, and select 3 stars on your own?
Well, we are gonna do that too, yeah.
So whether it will be matching or not?
Yeah, we are gonna do that.
Okay, so it's future. Okay, let's thank our speaker. And let's thank us all to attend this colloquium. Yeah, it was wonderful.